Okay, so we have arrived at this stage now. But for finding eigenvalues and eigenvectors, we can't continue from here because it is not of the form Ax plus b. Sorry, it's not of the form Ax equals to b. We have Ax plus b is equal to, let's say, something else as c. So now we need to convert this. So to convert this, we have to make a small substitution. Okay, and what is that substitution going to be? That's what we're going to see here. So if it's not homogeneous, so the next step what we would do is we'll take x vector is equal to x equilibrium sum vector plus x, I'm just using tilde for some other vector, okay? And I'm going to use this substitution to bring it to the form Ax plus b, okay? So if I'm going to differentiate this on both sides, so then I'll get d over dt of x equilibrium plus the x tilde vector would be a into x equilibrium vector plus x tilde vector plus the b vector which I'm having, which is the one right there. Okay, this is because we are saying the x prime vector is this one, right? So that's how this equation gets formed. All right, so when we have this, then we can say that we have to split what is there inside this. So we need to find d of x tilde vector over dt, right? And that would just be a times x tilde vector from this equation, okay? Because we have d over dt of x as ax plus b. So d x tilde over dt would just be a times x tilde. And this is also because we know that when we differentiate the equilibrium vector, we have to get a 0 or a 0 vector, okay? Because x equilibrium, we define the equilibrium one as the time rate to be 0. That's how we are defining that. So we want this to be 0. So automatically this becomes what we need, okay? So now if I'm saying just x tilde, I'm just going to use a different term here because I'm not comfortable using the tilde every time. So if I'm taking x tilde as y, then I would get dy over dt, it's a vector, right, is just a, the matrix A times the y vector. Okay, so now I'm having it of the form y prime is equal to ay, or ay is equal to b form. So now I can use my eigenvalues and eigenvectors to perform this. So I've converted this into a simpler form, right? And now I can perform the eigenvalues and eigenvectors for this differential equation, and I can come up with a general solution which will be of that form, okay? But a small difference over here is you need to convert it back because y is not what we need. We have to find x, right? X vector. So when I'm converting it back, I would have to do something like y is equal to phi of t plus x equilibrium, okay? And if this is the solution for y which you have found, right? If that was the solution for y vector, and then you have to add it to the x vector, because we say that x tilde is y, and we write x as x equilibrium plus x tilde, or this is y. So we found the solution for y, and then if we add the x equilibrium back, we are going to get the solution for the vector which we required, which is the x vector, right? So what is x equilibrium now? So X equilibrium is just going to be A inverse B. So my answer would be phi of t minus A inverse times B vector. So that would be my y. Okay. So this is how we change the equation around to make it homogeneous, and then we are going to solve it. Okay. So I'll see you in the next video.